Okay, welcome to this video. It's actually the third video in this part about factoring quadratics. This will be the third video. Remember that the first one was GCF. The second one was difference of squares. Right? So this third, and sum of squares, don't forget those. Alright, this third one is about factoring a standard form quadratic expression when a is equal to 1. Recall that a standard form quadratic is in the form of ax squared plus bx plus c. We've graphed these. We know how to find the vertex. We know how to find the axis of symmetry. In fact, we have to do that first. What we are going to now do is to unmultiply these. So let's go back for a second to review two things. This is our factoring notes. First, here, factoring. What does it mean? It means to unmultiply or to rewrite as a product. Secondly, the greatest common factor. This is what you do first always. So, even when we are working in our quadratic form that is in standard form, we still have to remember that we are unmultiplying or we are writing the product. And secondly, we have to first try a GCF. Alright? Let's look at something here about unmultiplying. This is familiar to us. If we were given this problem, x plus 3 multiplied to x minus 4, we would double distribute or FOIL, and we would get x squared minus 4x plus 3x minus 12. We would notice that these terms need to be combined to produce the product, the final product, x squared minus x minus 12. Well, again, as in the first one, our job in this particular case is to take the factor or the products and turn them back into the factors. In this case, I am looking for two factors. It would be x plus 3 and it would be x minus 4. Now this looks a lot like APQ form, x minus p and x minus q. In fact, we are taking standard and turning it back into an APQ. And remember that the A lives out front. Alright? But in all of these problems at this present time, our A is going to equal to 1. Let's see how this works. So, following our steps, first, what we have to do before we do anything is check this for a GCF. I notice that this last term has no variables, so I can't divide by x. I notice that this first term, the a, in fact, here, that a is equal to 1, and that means that I haven't really any values by which I can divide and come up with a common factor. So, our steps are now this. First, double check that a does in fact equal to 1. Second, we will factor the c. Third, we will choose plus or minus in order to make the b value. And lastly, we will write the two binomials in the APQ form. I'm going to work this problem here following these 4 steps. Alright, part 1. We already noticed that a is equal to 1. This is important because if it's not, we have a slightly different process when a does not equal to 1. So when a does not equal to 1, we have a different process. So that's taken care of. What we want to do is to factor the value c. So I'm going to find myself a small workspace here. Here's my little workspace right here. Like we did with the greatest common factor, I'm going to factor 18. So I know I'm working with 18, and I know that I can use 1 times 18, I can use 2 times 9, and I can use 3 times 6. If I were to try 4, 4 will not divide evenly into 18. 5 also does not divide evenly 18. 6 is the next number as I'm counting down, but I notice that 6 is actually represented here. So 1, 2, 3, 4 and 5 don't work, and 6 begins the process traveling up the right-hand side. What we have now, we have 3 different pairs of numbers to work with. We have the yellow set, we have the light green set, and we also have an orange set. We only have 3 pairs of numbers that we can work with. Why are these pairs important? Because these are the values that I must add or subtract in order to make B. Essentially, this whole process is what will multiply to make 18, positive 18, and I'm saying positive on purpose, yet in this particular case, subtract to make negative 7. And I got a bit ahead of myself. How do I know I'm subtracting? This symbol right there, the last symbol in the trinomial, tells me to subtract. That's how I know what I'm doing. To make, what is my B value? And my B value in this case is going to be negative 7. Negative 7. So I need to find numbers that will multiply to give me positive 18, and yet when I subtract them, will create negative 7. All right. I'm going to erase this. I need this space over here. Let me look at this first pair of numbers. If I subtract them, 1 minus 18 produces for us negative 17. This is not close to the value that we need. The second pair is 2 minus 9. That does produce negative 7, but I want to continue. Let's say 3 subtract 6. That produces negative 3. What I notice is that these values here are in descending order. That's very, very helpful when we're searching for our factors, for our binomial factors. It's obvious at this point in time that I need to use the 2 minus 9, which means I see that my 2 is positive and my 9 is negative. So, step number 4 is going to be to write the binomials. X is always what sits in the front. Then, again, I'm using a positive 2, and I'm going to use a negative 9. So in the first binomial, I need to record a positive 2. And in the second binomial, I need to record a negative 9. I've completed the 4 steps. And notice I've taken what looks like a standard form, an A, B, C, and turned it into what looks like an A, P, Q. This here is where I'm finished. Now, I can check. 2 ways I can check, if you remember. Here I'm going to check. I could take x plus 2 and x minus 9, and I could multiply it out, or FOIL it, or double distribute. This will give me x squared. This will give me negative 9x. This will give me a positive 2x. And this, 2 times negative 9, gives me a negative 18. When I combine my like terms, I end up with negative 7x minus 18. But the first term is going to be x squared. So I see that it checks out. A second process could be to use the calculator. Remember last time what we did is we took our values, our expressions, and typed them into the y equals. We put our original problem in y1 and our final result in y2. Now you'll notice that these are from the greatest common factoring video. So I'm going to start all over. What I'm going to do here, I'm going to highlight in green my original problem. This is what I want to put into y1. Into y2, I want to put this yellow expression here. Let's look. X squared. Subtract 7x. Subtract 18. Subtract the 18. Alright, next line. This is going to be where I enter my result, the one I want to check. Open a parenthesis, x plus 2, close that parenthesis, open another one, x subtract 9, close. Now, I could draw a graph, but it's quicker if I were to look at the table of values, and what I will want is my y1 values to match identically with my y2 values. Second graph. And I see that my y2 values all match my y1 values. So I know that I have factored this correctly. Let's try this again. Alright, what I did do is I made myself a list of steps just in case you forgot what we were talking about here. Okay? Alright, so, however, I do need to remember first, always look for a GCF. Always, always, always. In this first problem here, I did already look for the GCF here. It wasn't, this is the first problem we did. We're going to recall that the factored form is going to be x plus 2, and it's going to be x minus 9, and we are finished. We've checked this already. So we are finished here. Okay? Let's look at problem number 2. This looks very, very different. In fact, I see that if this a does not equal to 1, so I got to try something different. But wait, I have to look for my GCF. If I were to try to divide every one of these values by 4, I will see that I have something that actually does have an a equal to 1. So I already noticed that this here is my GCF. We found one. Which then makes this problem look like this. X squared minus 5x minus 17. I'm sorry, minus 14. I don't know why I said 17. Minus 14. Smaller eraser. Sorry about that. Minus 14. Now, this is what we completed in video number 1. Our job now is to look at this interior part and see, can we in fact factor this further? And in fact we can. We see that this on the inside is in fact an A, B, C, a standard form quadratic. This is a standard form, you can't see that over here, standard form quadratic. Where A is equal to 1. So, the process I'm going to complete are these first 4 steps. In fact, step number 1 is completed for us already. Step number 2, if you will recall, is going to be to factor the C value. Our C value is going to be positive 14. And I'm saying positive 14 because I'm going to leave this subtraction sign for later. Remember that this actually is in step 3. I must subtract to make the b, negative 5. I have to subtract to make negative 5. That's what this symbol says. So I need a workspace for factoring my c value. Here's my workspace for factoring the c. 14, if I factor it apart in an organized fashion, we produce 1 and 14. You would produce 2 and 7. The numbers between 2 and 7 that I need to investigate. I need to investigate 3, 4, 5, and 6. All of those values will not, I should say none of those values will divide evenly into 14. So I know that I am complete. Now what I need to figure out, which of these values will subtract and make negative 5? If I were to take 1 minus 14, I would get negative 13. That's not it. 2 minus 7 will actually equal negative 5. That's the set that I want. I will notice something else. My first value is a positive 2, and my second value is going to be the negative 7. So those are the two values I'm going to put into my binomials. So now, the binomials I create. Remember that x is in the front in both of these. The positive 2 is written here. The negative 7 is written here. I must remember to bring down the 4 as part of the problem, because whatever I've boxed up here, whatever I've written that I am done, I'm finished, I need this to in fact multiply and make my original problem. Alright, so another way to check this, we could, again, use the calculator. What I've taken the liberty of doing is actually typing this in before to save some time. This first line here, 4x squared minus 20x minus 56, is the original problem. That's what came first. The second one, 4, is the greatest common factor. Then I have x plus 2 multiplied to x minus 7. If I were to look at the table of values, the second table, I should see that my y2 is identical to my y1. These two lists match, which is evidence that I've done this correctly. Alright, let's move on. A little faster this time. I see that a does equal to 1. That's step 1 done. I need to factor the c. I'm going to make myself a small workspace here. This is going to be simple. 10 is going to factor apart into 1 multiplied to 10 and 2 multiplied to 5. The numbers 3 and 4 don't divide evenly into 10, so I'm finished with part 2. Part 3 says I must choose. Well, this symbol here tells me what I've got to do. I must add to make positive 7. That's what I need to add. Well, 1 and 10 makes this equals to 11 if I add it up. 2 times 5 is equal, 2 plus 5 is equal to 7. That's the set I want. Notice I'm dealing with a positive 2 and a positive 5. So my binomials are going to be x plus 2 and x plus 5. Notice I've parked the x in the front. Here, I have no GCF and I am finished. Alright, next problem. Looking at this one here. I just lowered the page so I have a little more workspace. Not a equals to 1, but remember, first is a GCF. Must do this first. So, I look and I see that each of these terms can be divided by 2. What I have as a result, there is my GCF. Inside, I will be left with x squared minus 5x plus 6. I now see on the interior, this inside section is what I now want to focus on. This is a standard form quadratic where a does equal to 1. So I can proceed. That's what I needed to make with this whole process. So let's look at our steps one last time. I already see inside here that a equals to 1. What I want to do is I want to factor apart the c. Here is a small workspace for this. This one's really kind of simple but can be deceptive. I see that I have 6. It's going to be 1 times 6 and 2 multiplied to 3. That's it. My third step says that what I want to do, I want to add in order to make -5. Well, in this particular case, if I were to do 1 plus 6, I will end up with +7. Notice the sign's incorrect. If I were to do 2 plus 3, I would equal with a +5. I don't want positive, I in fact want negative. Here's where it's important to focus and pay attention. I am in fact looking for numbers that will multiply to make a +6 and yet will add to make -5. Here's the thing we must remember. It is true 1 times 6 gives you 6, that 2 times 3 gives you 6, but we must remember that a -2 multiplied to a -3 will also create a +6. The reason why this is important is because a -2 plus a -3 are the values that will give us our -5. So, how do we understand what to do? I've added 1 and 6 and got 7. It's the wrong value entirely. Added 2 and 3 and got 5. It's the correct value but the wrong sign. In this particular case, I need to remember that I'm adding. So I'm going to add negatives to everybody, because -2 times -3 will at the same time produce a +6 if I multiply and a -5 when I add them together. So then my two binomials are going to be x in the front of both. Notice I'm dealing with a -2 and I'm dealing with a -3. Those are the values I've added. -2, -3. I need to remember to bring down and include the GCF. In this case, I can check this and I will find that it works. I am finished. If ever in doubt, always check. All right? Let's continue. All right. Again, we have one of these. Looks a little bit different because I see a complicated set of variables here. But first, always first, GCF. I put these together to contrast them. What I notice here is that there is a GCF. I notice here there is not a GCF because this guy does not have y. This guy has no x, so there's not a GCF here. We'll talk about this in a moment. Starting here, we see the GCF is going to be y. I write the GCF out front. Here, I am left with x squared plus 6x minus 16. Following the next several steps, I recall that this a does equal to 1, so I'm moving on to step number 2, where I'm going to factor apart the c. The c in this particular case is going to be 16. 1 multiplied to 16, 2 multiplied to 8, 3 does not work, and 4 will multiply to 4. This symbol says that I'm supposed to subtract to make 6, positive 6. If I subtract here, I'm going to equal, if I subtract here, I'm going to equal negative, I want this wider. If I subtract this, I'm going to equal negative 15. If I were to subtract this, I'm going to equal a negative 6. I'm going to stop here. Well, actually, this would produce a 0. But I want to focus here because I see the right value, just the wrong sign. If I do, 2 subtract 8, I'm going to end up with a negative 6. I want a positive 6. Because I'm subtracting, I'm going to reverse the two values I'm subtracting to use 8 subtract 2. This will give me a positive 6. This is different than when we added. The point being, I need two numbers that will multiply to make positive 16, and yet will subtract to make 6. If I were to in fact use the trick before where I just added negatives, I would mess up that process. I would not be able to multiply to make a 16 and subtract and get 6. So the binomials I'm going to record are going to be x. Notice that the first value I have is a positive 8. The second value I have is a negative 2. So I'm putting positive 8 here, negative 2 in this one, and putting my x in the front. I must remember that I have a GCF of y. In this particular case, I am finished. If you multiply this back together, you will end up with the problem that you started off with. This next problem is slightly different in the fact that I have a complication. I have y's. So what I end up with is I have an x squared, I have an x, and I have no x here. What I have coming the other direction, I have y squared, I have y, and I have no y here. This is a pattern that is quadratic. It is in the same pattern, but it's a little different. So I need a different set of steps to follow. Alright, so here's what we're going to do. If you have a situation that looks like this, what we're going to do is we're going to write the problem without the y values. So we're going to write the problem as though it had no y's in it at all. So we're going to rewrite. And actually, I'm going to write it over on the side. I don't want to write underneath myself. So I'm going to rewrite over here. Pretend that I have x squared minus 13x minus 30. This is what I'm going to work this problem. At the end, when I've got my two binomials, I will then just write the values y in the back of the two binomials. So essentially, I'm pretending there is no y, and at the end, I'm going to write the letter y here, and include the rest of my parts of my variables, or my binomials. Let's give it a shot and see. So, I notice I'm dealing with a equals to 1. I need to set up, I have to factor the c. This one's a little longer. So, I know that 30 is made out of 1 times 30, 2 times 15, 3 times 10, and that's it. The numbers between 3 and 10, I lied to myself. I'm sorry. 4 doesn't work, but 5 and 6 do. I almost didn't complete the process. I noticed that what I need to do in this particular case is I have to, here, I'm supposed to subtract to make negative 13. 1 subtract 30 is not going to be. 2 subtract 15. 2 minus 15 does in fact equal my negative 13. So I will notice that my first value is going to be a positive 2. That positive 2 is going to be written right here. Notice what I've written is plus 2y. My second value is going to be a negative 15, and that is going to be written in the back minus 15y. In the front will be written my x and my x. Now, if I were to multiply this back out, I am now finished. If I were in fact to multiply this back out, x times x would give me x squared. X times negative 15y would give me negative 15xy. 2 times 2y times x will give me a positive 2xy. And last, 2 times negative 15 will give me a negative 30. I should have said 2y and negative 15y, y squared. Combining my like terms will give me my result. With my x squared in the front. And I've checked. I'm checking here. I'm actually done here. I'm just checking to see that I've gotten it correct. All right? One last bit and we are finished. But I should say, whenever you have x squared x, no x, y squared y, no y, remember this is the process. Pretend that it has no y's, factor it, and put the y's just right back in the back. Always check your math to make sure you're doing okay. Last part of this video. Given the graph, find the factors. What are the apparent factors of the graphs below? The easiest thing that this is asking us to do, really, if we were to write the a x minus p x minus q form, these parts are the factors. This binomial here, this binomial here, I wanted to highlight it in yellow. And if it's fairly obvious, the a value are the factors. In this case, there are 3 factors. Let's see what we come up with here. Here and here are my roots. Remember that this is negative 3, so the a value, the p value, and the q value, p could be equal to negative 3. Q can be equal to positive 1. And the a value we see is going to be negative 1. If I were to write this, negative 1 multiplied to x plus the p, I'm sorry, minus the p, which actually gives us a positive 3, and x minus the 1, we are finished. I have my 3 factors. Again, factors are going to look like a, x minus p, x minus q. Here, I notice that my factors here, my a, my p, my q, 1, 2, 3, 4, looks like a negative 4. 1, 2, 3, looks like a 3. The a value, this is messier. From here to here, looks like up a half. This should be up 1 to 2, if I go over 2. The a value is a little bit difficult in this case. I'm going to say over 1 up a half, over 1 not quite. I'm going to say 1/3. I'm not sure of this. I don't want to spend the time working on this. What I do know is the binomial parts are going to be x plus the 4 and x minus the 3, and we're going to put a out front because it's undetermined. All right, that's it. We will call this finished for now. If you have questions about this, please, 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 please practice these. All right, thanks.